The overall goal of this experiment is to synthesize a novel zinc oxide nanostructure on graphene using hydrothermal technique and demonstrate that it exhibits enhanced piezoelectric performance.
This method can help answer key questions in nanomaterial field for electronic and optoelectronic applications such as photovoltaics, biosensors, as well as wearable and implantable electronics. The main advantage of this novel nanostructure is that it could enhance not only the number of nanorod, but also the specific surface area in a given region for piezoelectric nanogenerators.
Generally, individuals new to this method for graphene transfer will struggle because it is not easy to place the floating graphene on desired position of substrate. I first said ideal that I could apply this novel structure to Nanogenerator for improving the performance when I found that zinc oxide nanorod can grow on both sides of the graphene.
The graphene used in this study is grown on copper foil using the thermal chemical vapor deposition or CVD technique. To begin, wash the copper foil with a mild flow of acetone, isopropyl alcohol, and distilled water respectively. Place the cleaned copper foil in a 2-inch quartz tube in the furnace, and then purge the furnace chamber with vacuum for 10 minutes by using a rotary pump. Configure the temperature of a digitalized furnace to ramp up the furnace to 995 degrees Celsius while maintaining the desired flow rates. Introduce the 20 SCCM of methane for 10 minutes to grow the single-layered graphene. Maintain the 80 SCCM of